So, have you ever really stopped to think about what's going on in your head when you're just lost in thought? Today, we're going to dive into a pretty wild new idea from neuroscience. It frames thinking not as just some abstract process, but as a journey.
You know that feeling, right? When you're just thinking about something and one idea leads to the next, and suddenly you feel like you've actually gone somewhere in your head? It's a really common feeling, and it turns out it's not just a metaphor. Not at all.
And I mean, this isn't just some poetic idea. Cutting edge neuroscience is seriously starting to frame the act of thinking as a form of navigation. We're not talking about walking through a city, but navigating through the huge structured landscape of your very own mind. Okay, so how in the world does that work? Let's start with the basics. First up, section 1, drawing the pathways. I mean, you can't navigate without a map, right? So check out this super simple but really profound example. You think of the word dog. Your mind might almost instantly hop over to cat. From there, maybe a bigger cat, like tiger, and then maybe lion. See? That's not random. It's a journey along the strongest, most well-worn connections on your mental map. And this mental map, it actually has a scientific name. It's called semantic space. The easiest way to picture it is as this giant invisible network where every single thing you know is a specific location, a little node on the map. And the key thing here is that the distance between these nodes isn't about miles or inches, it's all about how related they are. Now, here's where it gets really interesting. This map isn't flat like a piece of paper. It has a real topography. So in section 2, we're going to explore the valleys of thought to really get a feel for this mental terrain. Exactly. Our minds have these preferred pathways, these grooves that have been worn down over time. Some thoughts are just easy. They feel natural. But others, man, they require a real mental climb. And that's because our mental landscape kind of has its own gravity. This mental gravity pulls our thoughts toward what scientists call stable states, or attractors. A great way to think of them is like deep valleys in the landscape. Once a little thought marble starts rolling, it's just so easy for it to settle down there. These are our comfortable go-to thought patterns. The unstable states, though, they're like trying to balance that marble on a sharp mountain peak. It takes a ton of effort to get it there and to keep it there. But, okay, this is a really crucial point. When scientists talk about energy in these models, we're not talking about the calories your brain is burning. It's not that kind of energy. This is more of a mathematical concept that just represents how stable or how probable a certain thought pattern is. A low-energy state is simply a more likely, more stable place for your brain to hang out. And this brings us to the million-dollar question, doesn't it? What's the real connection between this abstract map of ideas and the actual physical 3-pound organ sitting in our skulls? That brings us to section 3, the map versus the territory, where we'll look at the link between information and good old physical energy. So on one side, you've got the real stuff, the physical energy of the brain. You're talking about actual electrochemical signals, your brain burning through fuel, all that jazz. And on the other side, you've got this abstract idea of informational energy, which just describes how our thoughts are organized. For a long, long time, scientists saw these as two totally separate worlds. So, are they connected? Well, a really fascinating field called information thermodynamics is bridging that exact gap. And the answer it's giving us is a definite, resounding yes. Turns out how you organize information has very real, very physical consequences. And get this connection is so real, so fundamental, it's actually described by a law from physics called Landauer's principle. Now, don't worry about the equation. Don't get hung up on the math. What it proves is absolutely mind-blowing. It means that any little bit of information processing, even something as simple as erasing one bit of memory, has a minimum, unavoidable physical energy cost. The big takeaway here is that thinking isn't just some abstract thing. It's a physical process, and it has to obey the laws of thermodynamics. How cool is that? Okay, so if thinking has a physical cost, does that mean it also has physical motion? Well, that leads us right into section 4, where we're going to look at a theory that tries to describe the actual physics of this navigation, the Brain Kinematics Model. All right, I know this slide introduces some new terminology, but stick with me. The core idea is actually pretty simple. The Brain Kinematics Model, or BKM for short, basically says that our memories are stored in these little structural units. Thinking, then, is the flow of neural activity, what the model calls neural strain, that's moving across these units, and it's all happening inside this larger field of interacting brainwaves. So let's redefine our whole journey idea.
Inside this BKM model, a thought trajectory isn't just hopping between concepts anymore. No, it's a physical path of neural activity. It's a flow that's guided through your memory networks by the pull of your emotions and by the coherence of a particular theme. It's actual motion with direction and momentum. Okay, so let's put this into practice. This all makes sense for logical, step-by-step thinking. But what about those times when our thoughts don't follow a straight line at all? Let's jump into Section 5, Creative, Dreamlike Journeys, and talk about what it means to go off-road in this mental landscape. We can basically think of two main modes of travel here. Convergent thinking is like following a really clear highway to a single destination. All your thoughts are merging and leading to one single coherent answer. But divergent thinking, that's totally different. That's when you keep multiple pathways open, which allows for exploration, for creativity, for making all sorts of new connections. And this is where the model just gets so powerful, you know? It helps us explain things that might seem totally chaotic, but are really just different forms of navigation. Think about Cubistart, which shows you multiple viewpoints all at the same time. Or a dream, where you jump between scenes based on a feeling, not on logic. These are all just journeys without a single fixed destination. So the big insight here, the main takeaway, is that creativity, mind-wandering, even dreaming, these aren't your brain's compass being broken. They are incredibly sophisticated, totally valid modes of navigation. They're just exploring the mental landscape with a different set of rules and a different kind of goal. Thinking about your mind as a landscape that you can actively navigate, well, that's a real game changer. It means you're not just a passive passenger along for the ride with your thoughts. You're the explorer. You can choose to go deeper into the valleys of your expertise, or you can decide to intentionally climb a new peak just to see a different view. Which leaves us with one final thought. If thinking really is navigation, what new landscapes will you choose to explore?